All right, I have the top of the hour, so we're going to get started. I'd like to welcome everyone, and I hope you're all having a good day. So the focus of this presentation is on improving energy sector resilience with geocells and ground protection mats. I'm your host, Corey Schneider, a business development manager with Presto Geosystems. We are located in Wisconsin and manufacture erosion control, stormwater management, and porous pavement products that are used all over the United States and the world. I have everyone muted now, so if you have questions during the presentation, please type them in the question window and I will answer them at the end. Today's presentation will cover geocell development and how geocells are used, specifically in the energy sector, and how they help with touch and step hazards. We will also discuss GeoTerra construction mats, both permanent and temporary applications, and highlight some successful GeoWeb and GeoTerra projects in the energy industry. First, a little background on Presto. We worked with the United States Army Corps of Engineers to develop geocell technology in the late 1970s and have been innovating ever since. The products have been used in over 200 countries and in every state in the US. We go beyond simply providing a product. You can find a lot of design and construction resources on our website. We also have experienced engineers on staff, which allow us to provide free project evaluations for any project where you are considering using a Presto product. And how that works is you fill out a short form on our website, and within a couple of days, we will recommend a specific product as well as anchorage that would be necessary for you to have a successful project. And we would then copy our local distributor in, who could get you budgetary numbers shortly after that. So if you do decide to use us, we also provide contractor support. So we'll make sure that the installation not only goes in correctly, but also as efficiently as possible. And as I just mentioned, we do have a distribution network that we sell through. So we have local support available for any projects that you might be working on. And we do all of this with an eye toward providing a complete solution for your project. We operate in 3 product areas. We have our GeoWeb geocells, which can be used for load support, slope and channel protection, and constructing green retaining walls. We also have a line of porous pavements, both vegetated and aggregate solutions, and lightweight reusable construction mats. We're going to cover a few areas today, focusing on the GeoWeb system in different applications and talking about the reusable construction mats as well. As I mentioned, we worked with the Army Corps of Engineers to develop the GeoCell system. The initial iteration used wax paper in order to be water resistant, but that wasn't strong enough. So they made some out of aluminum, which had the strength, but was difficult to ship and install. Finally, a high-density polyethylene, or HDPE, was the chosen material due to its lightweight, flexible nature and the fact that it is inert to nearly all chemicals and climate conditions. We'll now get into a little general information about our GeoWeb geocells. The GeoWeb system is our version of geocell technology and consists of 2 main attributes. The first is the cell or container size. The cells come in 3 diameters, small, medium, and large openings, with cell heights of 3, 4, 6, 8, and 12 inches available for each diameter. The proper combination of cell size and cell depth depends on the project details. And with that project evaluation, we can help you determine which one is the most appropriate for your specific application. There are also 5 different section lengths to best fit your needs. The ultrasonically welded seam, where all of the connecting points are, is very important to the function of a geocell. The stronger the seam strength, the better the performance of the geocell will be. A strong seam allows for heavier infill material, steeper and taller slopes, and better lifetime performance. GeoWeb is produced using high-quality virgin, high-density polyethylene resin for consistently strong welds at cell junctions, while also maintaining semi-rigid ductile properties within the cell walls, high stress crack resistance, and overall toughness and long-term durability in the environment. Our geocells do not use fillers or exotic polymer alloy blends, which can ultimately reduce weld strength and environmental stress crack resistance, and that are offered in some competing products in the name of increasing wall stiffness. To avoid well failures and the damaging effects of differential settlement, uniformity in performance across all elements of a geocell is much more important than stiffness alone. Here you can see a typical GeoWeb panel. It comes tri-folded, banded, and palletized. Each section has a nominal width of 8.5 feet with lengths up to 58 feet. The panels are flexible, opening like an accordion, so they can follow the natural contours of the work site without being confined to a rigid set of dimensions. The sections can also easily be cut in the field to fit project dimensions and or go around any obstructions such as trees, manholes, or guardrails. The second main attribute of the GeoWeb system is the infill, or what you put into the container. An important benefit of the GeoWeb system is that even a low quality aggregate, sand, or certain salvage material can be used to infill the cells. Using salvaged aggregate or sand can save significant amount of money on material and hauling costs. We can also eliminate fines when desired, since the cells provide the confinement and aid compaction of cohesionless soils. Without fines, you can significantly improve drainage and let the water flow freely through the system, preventing pore pressure buildup and global failure of the cross section. The ability to use sands and low quality aggregates really sets the three-dimensional GeoWeb system apart from planar geogrids and geotextiles. Those products require high quality materials with very high friction angles to achieve optimal performance. With the GeoWeb system, low friction angle materials are just fine. The GeoWeb panels achieve their full potential even with these poor materials, which can be a huge cost savings. In order for a geocell system to perform uniformly, it is critical that both the factory welded junctions, or the internal junctions, and field joined junctions that connect individual panels, the mechanical junctions, perform at a level that is commensurate with that of the cell walls. Therefore, an incremental improvement in one characteristic, such as wall stiffness or environmental stress crack resistance, is only valuable if a complementary improvement has been made in the other components of the system. GeoWeb is manufactured using a proprietary blend of high-quality virgin, high-density polyethylene. Our proprietary formulation has stood the test of time for more than 40 years and contains no fillers, unstable polymer combinations, or exotic polymer alloys. For most typical sites, GeoWeb will retain its durability for over 100 years, with lab testing indicating 149 years without degradation, even at full exposure to the elements. We stand behind our numbers so you can deliver certainty in the solution as you build with materials you can trust. Additionally, GeoWeb and all of our other products and accessories are 100% made in the USA. Presto's GeoWeb system is equipped with numerous design and construction components that can increase strength and speed of installation. When using stake anchorage, we can provide a simple cap or a standard number 4 or 1/2 inch diameter rebar, or we can also provide fiberglass or plastic anchors when necessary. The ATRA key is used to connect sections together, both side to side and end to end, creating one fully integrated uniform system, no matter how many sections are connected together. It allows for faster installation of the GeoWeb and will last the lifetime of the project, ensuring that the covered area is protected and that the GeoWeb system will not fail under anticipated stresses. The specific engineering values of the ATRA key will ensure the system holds up to loading over time without the corrosion seen in staples or the failure of underperforming cable tie systems. Connection methods recommended by our competitors. Our spec sheet calls out the specific engineering values for this patented connector. For steep slopes where the native soil is highly erodible, or over a surface that cannot be punctured, such as a geomembrane liner, tendons can be used. The ATRA tendon clips transfer the load from heavy infill material to the tendons and crest anchorage system. Only the ATRA tendon clip is specifically designed to fully transfer safely and securely the forces placed upon the geocell. Every accessory and every feature has been designed and tested to specifically work together so that we go from problem to design to construction solution with a system where the modeling replicates the real world forces. Now that we have some background on geocells in general, we'll turn toward the energy sector specifically. The first thing we'll cover is how the GeoWeb system works at the surface to create a stabilized unpaved road. An aggregate surface has advantages in saving pavement costs, and with the GeoWeb system filled with open graded base course, you can design a system that allows stormwater infiltration and provides stormwater storage. The purpose of cellular confinement is very simple: to stabilize the movement of unstable soils, both horizontally and vertically. The weaker the subgrade conditions, the more practical the insertion of the GeoWeb system is into the design. There are many great benefits to using GeoWeb. The one I want to highlight for you is that the system allows for the use of sand, low quality aggregate, or on-site or salvaged material, so you don't have to truck in expensive engineered stone. You can use what is on-site to save on cost and installation time. Again, this is a big benefit over other geosynthetics like GeoGrids, which require specific gradations of high quality stone. Additionally, by controlling differential settlement, GeoWeb can greatly reduce or even eliminate rutting, helping to control maintenance costs. On the construction end, GeoWeb can be installed in any weather conditions and allows for immediate access, unlike when chemical stabilization is used. And it can also reduce your overall cross section by 70% compared to non-reinforced sections. The GeoWeb system is suitable for use in extremely soft subgrade conditions. In fact, the worse the subgrade is, the more sense GeoWeb will make. Here you can see the impressive load support benefits of an 80,000 pound loaded dump truck on a partially filled GeoWeb panel over a soft subgrade. You can see how the cells push back against each other to support the load, and that only the adjacent cell needs to be filled for support to occur. The great benefit to using the GeoWeb system is that you don't need to have every cell completely filled before the road is usable. You can reduce construction time and materials with this approach, a significant benefit of using the GeoWeb system. The three-dimensional system works in this way. When a vertical load is applied, the active earth pressure in the loaded cell pushes back against the passive earth pressure in the adjacent cells to form a stable system. Each cell helps support the ones around it. The GeoWeb cell walls also transfer hoop stress, which is important in keeping the system intact and creates a mattress effect. The strength of the seams around each cell, the material properties of the individual strips, and the connection method between panels are all important factors in determining how the GeoCell system can improve load-bearing capacity. Strong seams, semi-ductile resin properties, and integrated connections are critical to a well-performing system. The GeoWeb system and accessories are specifically designed to work together to be an effective solution for roads in soft soil locations. Here you can see the stresses on the subgrade with the unsupported subgrade on the left and the GeoWeb reinforcement on the right. Notice how there is a complete elimination of the high stresses at the surface when using the GeoWeb reinforcement. The stresses are reduced and distributed over a wider area known as the mattress effect. This mattress effect reduces stresses reaching the subgrade and leads to significant decrease in deflection and rutting. By eliminating lateral particle movement, the GeoWeb system can stabilize the surface, eliminating the need for constant maintenance. So now we're going to look at a couple of project profiles, specifically load support in the energy sector. This first project was for the Wheatstone liquid natural gas facility in Australia. The equipment was brought in by ship, assembled, and then moved 10 miles inland to the facilities. The vehicle to move the equipment was huge, as you can see here. So the roadway had to be built strong enough to handle the load without rutting or settling. The high number of passes was also a concern, as the heavy loads would cause some serious damage to pavement over time. We worked with the project engineer to design an aggregate surface roadway that would withstand the vehicle stresses and that could be built quickly in a remote environment. This solution used 2 layers of GeoWeb, which is rare, with the top layer intended to absorb stress and help evenly distribute the loads, and the bottom layer in place to aid in compaction and reduce settlement. This is a good photo of the construction sequence for this road, from the port in the upper right heading to the LNG facility in the lower left. The geotextile, which is the white fabric you see in the lower left, goes down first on the native subgrade, then the GeoWeb panels are installed. The empty panels are black, and you can see the native on-site material being used for the infill material. Being able to use the excavated material was a huge bonus to the GeoWeb system here, since it would have been very difficult to get the required amount of engineered aggregate out to this remote site. Here's a project that allowed for access to oil resources in Western Canada over undeveloped, soft, spongy subgrades. You can see that readily available sand infill was used, so expensive aggregate wasn't necessary to transport in. In most cases, the system can also reduce the depth of the cross-section by 70% or more. Here, we reduced the original section of 40 inches of imported aggregate to just 8 inches with an enhanced woven geotextile, 6-inch GeoWeb filled with on-site sand, and then a 2-inch imported aggregate wearing surface. This is a Duke Energy project in Florida to install new transmission towers through wetlands. The high winds of Hurricane Michael demolished over 100 towers, all of which had to be restored over this extremely wet subgrade. In this case, an enhanced woven geotextile was placed over the subgrade. Then the GeoWeb material and sand fill were placed, creating access and maintenance roads, as well as pads around the tower. In all, 2 million square feet of GeoWeb panels were used, with the system acting as both the construction access and the long-term maintenance road. You can see here the natural subgrade through this location. The water table is at the surface and boot prints are more than 1 inch deep, which means the sand here is extremely soft and definitely can't support trucks or construction equipment. The geotextile we used was Murify's RS 580i with a tensile strength over 5,000 pounds per foot. Not only is it an extremely strong fabric, but it also has wicking capabilities, quickly moving water out of the pavement section. The GeoWeb system works well with pretty much all other geosynthetics to create the best solution for a given project site, depending on loading requirements, drainage issues, or any other concerns you may have. And here we are at mid-installation. You can see the empty GeoWeb panels in the background of the photo. During construction, again, the contractor can use the GeoWeb road as soon as it is filled in. Pretty useful when you're trying to minimize the impact of construction on the surrounding environment. Here we have another energy project in Florida, again through very wet, soft soils. In some locations, there were actual low water crossings where water would be slowly flowing over the top of the road. This was not a problem when using the GeoWeb system. Given the site hydraulic conditions, we can even recommend the required stone size to prevent long-term washout, which we'll discuss more a little bit later. Because it was important to not interrupt the potential water flow through this wetland area, a high-quality open-graded aggregate was used. The GeoWeb panels themselves don't impede water flow since they are so open, so there's minimal disturbance to the environment, which is sometimes required by local regulations. Here's the completed access road. It is perfectly fine to see the top of the GeoWeb panels in roads like this. The system is fully functioning and you aren't going to damage the panels as long as they remain full. If you do see a little bit of emptying, we do recommend that you top dress the cells periodically just to prevent damage at the surface. This substation access road in Louisiana was originally designed with GeoGrid reinforcement, but due to low CBR values, it was switched to GeoWeb with sand infill. Notice how easily curves are created. Orientation of the GeoWeb, whether it's expanded across the width or down the length of the roadway, has no bearing on its effectiveness. Whichever direction makes sense based on roadway dimensions is acceptable. Again, we get an idea of the construction process. You can dump the infill material in piles directly on top of the GeoWeb panels, then use a dozer or rake to push the material into the open cells to fill them. And again, here we see the completed access road. Next, we have a wind energy project in Germany using a combination of sand and aggregate infill from on-site sources. Large equipment was used to move the wind turbines, so this road had to be very durable. Typical turbine will require 50 concrete trucks, steel reinforcement, the tower, the blades, and the turbine accessing the site over the course of a few months. Axle loads are usually around 20,000 pounds. To handle these loads, 12 inches of sand was confined within the GeoWeb panels, which helped distribute the load and significantly reduce the vehicle stress seen by the native subgrade. Again, note the geotextile that was placed below the GeoWeb panels for separation. Here I want you to notice the ruts that are occurring where the cells are overfilled, but the rutting stops at the top of the cells. This is exactly how the GeoWeb geocells are supposed to function. The overfill material is called a wearing surface and helps compact the material into the GeoWeb geocells as it is driven over. Here we have the completed project with the wind turbines going up. You can see the large crane in the background for an idea of the types of vehicles that the system can support. A solar farm in Brandywine, Maryland was developed at an abandoned quarry site, leading to some areas with poor soil conditions. Vanguard Energy required a site access solution to allow safe, long-term access for maintenance and emergency vehicle access. While traffic is infrequent, the roadway needed to support up to 70,000-pound fire trucks. For stormwater management reasons, they required a permeable roadway. Vanguard reached out to Presto Geosystems for a solution that could support the required loads while maintaining permeability. We recommended our GW30V6, which is the mid-size cell 6 inches deep over a non-woven geotextile. In all, 39,000 square feet was installed and infilled with a mixture of on-site material, imported stone, and topsoil in order to build a vegetated roadway capable of supporting heavy vehicle loads. This mixture, which we refer to as an engineered fill, was used to support long-term vegetation while still providing load support stability. If vegetation is not required or desired, a clean sand or clean crushed aggregate can be used as infill and still provide a permeable surface. One of the biggest questions we get is about cost, which of course is no surprise, especially if this is a new technology for you or your area. So the GeoWeb system costs are compared here with other stabilization techniques. We've got the GeoWeb system for a load support application, in this case, a gravel surface road. Shows the difference in both price and cross-section depth for an aggregate only unreinforced section, a section using geogrids and geotextiles, and then two sections showing the use of the GeoWeb system, one with aggregate and one with salvaged on-site materials as the infill. You can see the GeoWeb system is both thinner and less expensive than the other methods, significantly so when on-site material is utilized. In fact, a 40% savings can be realized compared to the geogrid geotextile section, which again does not allow for the use of most salvaged or on-site material. Of course, your aggregate costs and distance to quarries may vary, but this will give you a general idea of the savings that can be achieved. Next, we'll briefly discuss the benefits of using GeoWeb at electrical substations. GeoWeb works quite well in electrical substations, locations which have some pretty specific requirements and needs to help protect workers. Using an open graded base course is essential and easy to do with the GeoWeb system. And compared with an unreinforced system, there's very little maintenance required over time. The GeoWeb system allows for water drainage and doesn't need to be heavily compacted, so it is quick to install. For this project in Tampa, Florida, GeoWeb was used both as the access road to the site and the working platform around the transformers. The GeoWeb allows for good water infiltration, so there's no ponding at the surface, which is a big safety hazard on electrical sites. As many energy projects need to deal with stormwater and potentially steep slopes, we'll now go over both channel and slope protection, starting with channels. A typical section might have concrete or aggregate below the normal water level, depending on flow characteristics, many times transitioning to topsoil and vegetation in the flood zone to provide as natural looking of a section as possible. GeoWeb can be placed along the embankments of stormwater channels and ponds to help prevent erosion due to fluctuating water levels. Low flow situations are easily handled by vegetated GeoWeb systems, creating a natural looking embankment without intensive maintenance requirements. The GeoWeb does not need to cover the bottom of the channel if continuous low flow water is present, and the type of vegetation within the panels is not important to the function of the system, so choosing plants that are native to the area and are okay with the occasional soaking will be a big help in reducing potential maintenance. The vegetated GeoWeb system has a lower cost than a riprap line channel since you can use local topsoil and don't need to import large stones. There's less maintenance as well since riprap channels need constant inspection to replace lost stone and remove weeds. With a vegetated channel, the only maintenance is the occasional mowing, which can be done with your standard lawnmower with no special equipment required. And finally, vegetated channels have better aesthetics than riprap channels. It may not seem that way, but vegetated channels are actually a good solution for higher flows when stabled with the GeoCell technology and a turf reinforcement mat overlay. The improvement is incredibly high, with our system able to withstand 29 feet per second and 16 pounds of shear compared to just 5 to 6 feet per second with an erosion blanket only. This allows lower impact vegetated channels to be used instead of expensive high maintenance riprap, concrete, or articulated concrete blocks. One of the best things about the GeoWeb system is how much trust we have in the system working, and that is because we have the experience and research to back up what we are saying. Significant testing was done at Colorado State University in Fort Collins, which is considered one of the top hydraulic research facilities in the world. The facility is unique in that it is located under the Horseshoe Reservoir and has a couple 100 feet of static head and can achieve extremely high velocities and shear stresses in both their indoor and outdoor flumes. Vegetated infill testing was performed with two objectives in mind. The first was the ability to withstand high velocities and shear stresses, the main components you are going to think about in hydraulic situations. And the second objective was that we wanted to compare the performance of topsoil-filled GeoWeb with riprap and other conventional solutions, such as erosion control blankets and turf reinforcement mats. The test consisted of 6-inch deep panels filled with topsoil and surface protection, which is probably our most recommended cross-section for this type of project. Vegetation was established and grown to 6 inches to replicate field conditions. A total of 10 one-hour tests were performed in the outdoor flume with varying conditions, including flow rate and bed slope angle. The testing was done in accordance with ASTM D6460 standards, which covers both soil loss through scour and blade density. The ASTM standard considers a successful test when you have less than 1/2 inch of topsoil loss and at least 300 blades of grass per square foot. The blade density is important as vegetation growth is a key factor in overall long-term stability. Here's a quick comparison to show the impressive results. You can see that GeoWeb filled with topsoil can handle a velocity over 29 feet per second compared to 12-inch riprap, which comes in around 14 feet per second. You can also see that the GeoWeb and surface protection far outperforms a high-performance TRM alone and doubles the acceptable velocity and shear stress. The key takeaway is topsoil-filled GeoWeb provides 2 times the protection as 12-inch riprap and also doubles the performance of a standard TRM or erosion control blanket in vegetated condition. As an aside, we also tested the unvegetated condition and learned that GeoWeb improves the unvegetated performance of a turf reinforcement mat by 60%. So you get day one advantages in addition to long-term benefits. This solution is suitable for any situation where you have very high velocities but short duration flows. It allows you to maintain vegetation in areas that would previously have been concrete or very large riprap. We also tested aggregate channels, and for these tests, we used 3 different cell sizes and 2 different rock sizes and ran a total of 90 tests. So all of these data points allowed for a regression analysis to be performed And through that analysis, we come up with an equation which allows us to perform calculations. So now, given the bed slope and unit discharge of a particular channel, we can manipulate the rock size and cell size until our rock loss L is 0. When compared to traditional riprap sizing tools by Abson-Johnson and the Corps of Engineers, GeoWeb channels can reduce your rock size anywhere from 2 to 10 times, offering significant cost savings in not only your rock costs, but also transportation and installation. The large variance in size reduction is due to bed slope. The flatter the bed slope, the greater we can reduce your rock sizes. And finally, concrete filled channels. This particular project is a water conveyance channel in Colorado. It used a geomembrane, then a geotextile, then our mid-size cell 3 inches deep with 3,000 PSI concrete. Tendons were used for anchorage as we couldn't puncture the geomembrane. Studies done by the U.S. Bureau of Reclamation show that concrete-filled GeoWeb is the most cost-effective, lowest maintenance solution for their water conveyance channels. Once GeoWeb is installed, it acts exactly like a concrete form. Here, the concrete is pumped into the cells. It can also be poured directly in from concrete trucks if access allows for it. You then screed and finish right to the top of the cell walls. In the picture on the right, notice the flexibility of the system. It won't crack like poured in place concrete will. Again, we have very impressive results for the concrete filled version of the system. The 3-inch depth was able to withstand 36 feet per second and 21 pounds of shear. And we actually did not even fail the system, but rather maxed out the flume at those conditions. So generally speaking, GeoWeb is going to improve the hydraulic performance of whatever infill material you use. With vegetation, we promote infiltration and reduce runoff. With aggregate, we can allow for smaller, less expensive rock. And then with concrete infill, we don't need any other forms, and it will flex with subgrade deformation, minimizing cracking. Next, we'll go on to talk about slope protection. Using GeoWeb on slopes allows for steeper stabilized slopes that are resistant to erosion when compared to other methods. We list 1 to 1 or greater on here, and really it's all about the global stability of the slope. The way the GeoWeb is applied here as just a single layer superficial protection does nothing for global stability, but at whatever slope whatever slope angle you are globally stable, we are able to design a system to drape the GeoWeb over it and prevent superficial erosion. So the GeoWeb works in multiple ways to protect slope surfaces. It prevents significant movement of the soil by confining it in individual cells. And by separating soil into smaller segments, the system resists mobilization of the entire slope face due to hydraulic loads and prevents long-term erosion. It's important to emphasize that proper installation of the GeoWeb includes embedding it into the crest of the slope, which will prevent water from flowing beneath the system and undermining it. No rills or gullies will form beneath the GeoWeb and lead to failure. The system provides a way to fully vegetate slope surfaces that otherwise could not support sustainable plant life and increases the overall slope stability by interlocking with the vegetative root zone. Stone and concrete materials can also be confined within the GeoWeb panels, again on slopes that would normally be too steep to allow for natural stone slopes. Vegetated slopes are the most popular option because they can result in the most attractive slopes with little to no maintenance. So again, GeoWeb on slopes can be filled with several different materials depending on your project needs. Topsoil, aggregate, or concrete are all options. There's a lot of different options for the cross section on the slope depending on project details and needs. Different types of anchoring are available, as I briefly mentioned at the beginning. Our engineering evaluations can help determine the best system for your project needs so that you know you are getting something that works and not a one-size-fits-all solution. So now we'll talk about a few project profiles in the energy sector. Here's Devil's Canyon Pipeline in California. The sandy soil around the support structures for this pipeline were experiencing significant erosion due to wind and water flow. There was no vehicle access to many parts of the pipeline because the sandy soil just couldn't support vehicular loads. To both protect the support structures and allow pipeline maintenance access, the GeoWeb system filled with concrete was used. The system was fast and easy to install, even in this remote location. Here's a project to replace a deteriorating asphalt cover on the berms at a liquid natural gas facility. They needed to reface the primary and secondary dikes without disturbing them so that the facility did not have to shut down during construction. We used different anchorage methods because of the height difference between the primary and secondary containment areas. So on primary containment, we used a 6-inch deep cell with tendon anchorage, and on the shorter secondary containment slopes, a 4-inch depth with our plastic Atra speed stakes. And here we have the installation. You can see the GeoWeb installed on the primary slopes and partially filled on the left-hand photo and nearly completely filled on the right-hand photo. And then here we have the completed secondary dike in the foreground with the primary dike in the background. Spotsylvania Solar Farm is the largest solar farm east of the Rockies at 3,500 acres, and it has hundreds of detention ponds to handle stormwater runoff. A 2-to-1 slope into one of the ponds at the back of the site was causing the owner particular problems, as it had to be repaired several times using stone check dams, erosion control blankets, and turf reinforcement mats, with nothing working due to the large volume of water, the slope of the drainage area, and the fact that there is a road right at the top of the damaged slope, leading to high volumes and velocities. Eventually, the GeoWeb slope protection system was chosen as a solution. The slope was smoothed out and the GeoWeb panels placed over the prepared slopes using the tendon anchorage system. The tendons were tied to a dead man pipe that was buried in a trench at the crest. Then the trench and GeoWeb panels were filled with locally available topsoil. The slope was then hydroseeded and covered with a straw coconut blanket. Just 2 weeks after the install, after several high-intensity storm events, there is significant vegetation established with no gulls or rills forming. While the GeoWeb system is not always the lowest cost solution available, it can solve the most challenging erosion protection issues. And think of the cost savings if this solution was done first and the slope didn't have to be redone 4 times. A power company in West Virginia came to us with significant erosion on the hillsides near 3 of their transmission towers. Slopes varied from 1.2-to-1 to 2-to-1. This particular tower had a 2-to-1 slope that was up to a 55-foot vertical height. Our recommendation was to use our mid-sized cell 6 inches deep and anchor with 3 polypropylene tendons and an Atra tendon clip every 6 cell downslope. The panels were pre-assembled off slope for ease of construction, and the slope was graded as smooth as possible. The pre-assembled panels were pulled down the slope which I'm going to show here. So with pre-assembly, the only on-slope work is connecting adjoining sections side to side. This can greatly speed up the installation process and make for a much safer install, as workers aren't constantly on these 1.2 to 1 slopes on a regular basis. Cells were then filled and hydroseeded. And just 9 days after hydroseeding, we see vegetation beginning to take hold, which in combination with the GeoWeb will prevent erosion, ensuring the long-term stability of the towers. We'll finish with a brief discussion of our reusable lightweight GeoTerra construction mats. When you need access quickly for a temporary solution, our construction mats are the way to go. They are intended to be placed directly on top of existing grade, generally with a geotextile separation layer placed first, and don't need any infill material. The mats can support both tracked and wheeled equipment and vehicles. Testing from the University of Kansas shows that they are structurally equivalent to 12 inches of aggregate, offering significant savings in both placement and removal, as well as reducing the overall carbon footprint of the project. With both versions of the GeoTerra, and we have a Classic and a GeoTerra GTO, we recommend different laying patterns based on direction of traffic. Generally speaking, we want to create a layout that avoids long continuous seams. This is true of both the bricklayer and herringbone patterns, with the bricklayer suitable for unidirectional traffic and the herringbone for multi-directional. The side-by-side pattern can be considered for relatively lightweight and or very short-term installations. Depending on what we are trying to accomplish, several different geosynthetics can be incorporated into the cross-section. Design 1 and 2 are used to prevent rutting, protect turf, over sand, and or to create a uniform stable surface. We add the geotextile separation layer if we are worried about subgrade pumping. Design 3 is used over poor or wet soils to prevent rutting and subgrade degradation and contamination, and to create a uniform stable surface. In this design, a geomembrane is added to prevent subgrade contamination and is typically sandwiched between two geotextiles to prevent it from damage. Design 4 is suitable over poor wet soils to prevent rutting and to create a uniform stable surface, with the GeoNet incorporated to create an integrated drainable surface. And finally, Design 5 pretty much does it all, being suitable over poor wet soils, prevent rutting, create a uniform stable surface, prevent subgrade contamination with the geomembrane, and creating an integrated drainable surface with the addition of the GeoNet. So now we'll look at each one of the products a little more closely, starting with the GeoTerra GTO, which uses a plastic bolt connection method, making installation relatively fast. Here are some of the specs on the product. It's about 4.33 square feet when first delivered to site. But once you do the first assembly of both of these systems, they can be left in much larger mats. And notice we have a crush strength of 550 PSI and a bottom open area of about 20%. Again, the units are locked together with bolts to form a network of interconnected structural mats. And with this system, you can install about 150 square feet per man-hour using a cordless drill. Next, we have the GeoTerra, which is one of the lowest cost, if not the lowest cost, structural mats on the market today. The units are slightly larger than the GTO units at nearly 5 square feet each and weigh just 9 pounds, while the crush strength is less than the 550 PSI of the GTO it's still 420 PSI, which is nearly 4 times the loads applied in HS-25 loading. And again, testing at the University of Kansas showed that both GeoTerra and GTO are structurally equivalent to 12 inches of aggregate. With the GeoTerra, the units are locked together with a 2-piece padlock connection device to form a network of interconnected structural mats. The padlock allows for pre-assembling larger mats either on or off-site to provide efficient transportation and installation. And with the GeoTerra, our installation rate is about 100 square feet per man-hour. These mats are then easily transported in much larger mats on trucks or even by helicopter. And again, the units only weigh about 2 pounds per square foot. And finally, a couple of project profiles using our construction mats. Here, GeoTerra construction mats were used to access many of the non-paved areas of this gas refinery site in Brazil. Equipment storage was moved around as needed, so the temporary and reusable nature of the mats was key. They provided a place to keep equipment high and dry out of the wet clay subgrade, and it made it much easier for the workers to move around as well. They also used the GeoTerra to construct helipads to fly material and personnel in and out of the project site. Mats can be painted with signage as needed and then cleaned and if reused at another location. The GeoTerra mats can also be used in wet environments. This project needed a solution for quick access over soft ground. The water moved through the mats as needed without compromising the integrity of the system for the vehicles. They're typically placed over an enhanced geotextile, especially over soft ground like we see here, with the geotextile helping to provide a little bit of extra strength to the system and preventing the mats from sinking into the subgrade. And again, they're lightweight and easy to move. So the best thing to do is to pre-assemble the mats into sections that can fit onto whatever vehicle you're using for quick and easy deployment. As mentioned a few times, we provide a complete solution, and part of that is our technical assistance. The engineering team here at Presto works closely with engineers, offering free project evaluation for any roads, embankments, or erosion control project. The form is on our website, which is prestogeo.com. You can fill it out with as much information as you have, including attaching documents such as geotech reports, and it will come to us. Then within 3 business days, but usually faster, we provide a complete design evaluation, including infill recommendations, anchorage requirements, and design calculations. We will work with you to get you the best solution for your project. We deliver quality and over 40 years of expertise, guaranteeing each shipment meets or exceeds our specs, so you can deliver certainty and build with materials you can trust. We've made it faster and easier for you to obtain your PDH certificates. With our webinar dashboard, you can easily view our library of webinars and download PDH certificates for on-demand webinars completed. Your webinar dashboard will keep a record of on-demand webinars completed along with PDHs earned. Please note that certificates for live webinars are managed separately from the on-demand webinar dashboard. So you won't find your certificate from today in there, but you will receive an email from GoToWebinar within the next 24 hours containing a download link to obtain your PDH certificate. In 2 to 3 days, you'll also receive a separate email from Presto with more information about accessing the on-demand webinar dashboard with other helpful resources. If you do not receive either of the previously mentioned emails, please check your spam folder. So that concludes the presentation. Here's my contact info. If you do have any questions that come up later, feel free to call or email me. But now we've got about 6 minutes left, so I'm going to take a look at the questions that have been submitted during the webinar. First question is, why would recycled HDPE not be suitable? It's because the manufacturing process uses ultrasonic welding, and because recycled material varies, it's very difficult to get that ultrasonic welder set to the proper specs so that we can obtain the minimum weld strength that we require in our specifications. So recycled just does not weld very well. Has Geo been used on any permafrost installations in Alaska? Yes, it has. Person that sent that question, if you want to email me directly at corey.schneider@prestogeo.com, I can get you some examples. Has anyone done a study on the effects of GeoWeb panel on step and touch potentials for substation use? We have not done any studies, but it's a completely plastic material that has plastic connections and can have plastic stakes. And as long as we infill it with a clean stone, the GeoWeb certainly is not adding anything to the dangers of a step and touch potential. And then finally, is GeoTerra a relatively new product? Yeah, I guess it's relatively new. The original GeoTerra was developed maybe 12 or 13 years ago for oil exploration in the Amazon. And then we created the GeoTerra GTO about 5 or 6 years ago for a stronger, more robust system that was faster to install. So that looks like all the questions. We're almost at 1 hour here. So with that, we're going to end the presentation. I want to thank everyone for participating. And again, if you do have any questions that come up later, feel free to call or email me directly. Thanks everyone, and have a good day.